On March 5, 1982, the Soviet Venera 14 lander made history by successfully touching down on Venus, the second planet of the solar system. Operating for an impressive 57 minutes, it managed to capture and transmit a remarkable color panorama of its surroundings before succumbing to the planet's extreme conditions. Decades later, this image remains the most recent glimpse of Venus' surface available to scientists. Venus, often described as Earth's twin, shares many physical similarities with our planet, including size, composition, and density. However, these parallels end when it comes to habitability. Venus is a world of extremes, enveloped in a dense atmosphere of toxic, acidic clouds that render its surface deeply inhospitable. A runaway greenhouse effect traps solar heat with devastating efficiency, leading to surface temperatures averaging 464 degrees Celsius, 867 degrees Fahrenheit. The atmospheric pressure is equally unforgiving, almost 100 times greater than that of Earth, equivalent to the crushing depths of a deep ocean. Designing a lander capable of enduring these brutal conditions has proven a monumental challenge for scientists. Despite this, there have been successful attempts to gather data directly from the planet's surface. Between 1961 and 1984, the Soviet space program undertook an ambitious series of missions, dispatching 16 probes to explore Earth's enigmatic sun-side neighbor. In 1966, Venera 3 became the first spacecraft to penetrate the atmosphere of another planet, while Venera 7 in 1970 achieved the first successful soft landing on the surface of another world. Although none of the 8 Venera landers operated for more than 2 hours, with Venera 12 lasting the longest at 110 minutes, the program set unprecedented milestones. It was the first to transmit both images and sounds from another planet back to Earth. To date, Venera remains the only program to have sent visual and audio data from the surface of Venus. Venera 13 and 14 recorded sound, while Venera 9, 10, 13, and 14 captured panoramic images of their landing sites. Capturing photographs in the extreme conditions of Venus presented a significant engineering challenge. Placing a camera outside the lander was not an option, as the planet's intense heat and crushing atmospheric pressure would quickly destroy it. To overcome this, Soviet engineers designed a telephotometer system housed within the protective shell of the lander. Light from the Venusian surface entered through a specially designed porthole, was directed to a periscope device, and then transferred to the camera. This innovative solution proved successful, with the Venera 9 and Venera 10 missions in 1975, transmitting the first ever black and white panoramas of Venus' surface. Before these missions, some scientists speculated that Venus' surface conditions might cause extreme optical effects. Predictions ranged from significant light refraction, causing the landers to photograph themselves, to a thick atmospheric haze obscuring the surface entirely. However, the images revealed a much clearer view than anticipated. The Venera 9 panorama showed a rocky landscape, scattered with sharp-edged stones, while Venera 10 captured what appeared to be solidified lava flows. Neither fog nor the hypothesized refraction effects were present, allowing for an unprecedented look at the planet's surface. The next step for Soviet scientists was to capture color images of Venus. This task was entrusted to the Venera 11 and Venera 12 missions in 1978. Both landers successfully reached the surface and operated for over an hour, but their cameras failed to deliver panoramas due to a design flaw. The protective covers over the photometers failed to eject. Learning from this setback, engineers refined the design for the subsequent Venera 13 and Venera 14 missions. These landers, arriving on Venus in March 1982, transmitted the first and so far the only color panoramas of the planet's surface. The images revealed a harsh, golden-hued world shaped by volcanic activity and strewn with dark, basaltic rocks. For decades, These photographs remained humanity's only visual record of Venus' surface. The next significant breakthrough may come with NASA's Da Vinci Plus mission, slated to launch in the next decade. This mission plans to deploy a probe equipped with advanced instruments, including an infrared camera, to explore Venus' atmosphere and surface in greater detail. In recent years, advancements in image processing technology have allowed scientists to revisit the nearly 50-year-old data from the Venera missions. Researchers at Brown University have refined the original images, offering new perspectives on Venus' surface. The enhanced visuals reveal a forbidding, alien landscape bathed in a golden hue caused by sunlight filtering through the planet's dense, acidic clouds. Beneath this atmospheric tint, the rocks and soil appear dark gray, a characteristic attributed to their basaltic composition. This volcanic material dominates Venus' surface, supporting theories that the planet remains volcanically active today. Please subscribe this channel.